In this video, we will demonstrate the end-to-end configuration for sending data over TCP using the TagoTiP protocol, resulting in real-time data visualization on a TagoIO dashboard. TagoTiP is a text-based protocol designed for data transport. When used over TCP, you get guaranteed ordered delivery and a persistent connection that lets TagoIO servers push commands back to your device the instant they are ready, no polling required. We will start the setup by generating the necessary credentials. In your TagoIO profile, navigate to the Authorizations section and create a new authorization. Ensure the token format is set to TagoTiP. Once created, copy the token hash. This 16-character hex string is required in the payload to authenticate data transmission to your profile. With the token hash secured, the next step is to create the digital twin for your physical device. Go to the Devices section and click Add Device. Search for the TagoTiP network and select the TCP connector. During setup, enter a unique serial number. For this tutorial, we will be using 12341234. This serial number links the frames coming through the TCP connection to this specific device entry. Now that the device is registered, we need to identify the correct regional endpoint. You must target the endpoint depending on the server you created your account on. For servers located in the US, use US-E1. For servers in Europe, use EU-W1. The destination port for plain text TagoTiP TCP traffic is 5693. If you want TLS, use port 5694 instead. The frames on the wire are identical. Before sending the command, let's enable the Live Inspector to watch the data arrive in real time. Navigate to your TagoIO device and open the Live Inspector tab. Click Inspect. By enabling this now, we can verify that the TagoIO server receives and parses our data the moment we execute our command in the terminal. With the inspector running, we are ready to use netcat to send the payload. This exact string structure is what your IoT device will send to TagoIO. Now we will send a pipe-delimited payload containing the push action, your token hash, your device serial number, and your data. Because TCP is connection-oriented, netcat performs a handshake with the server before the frame is sent. No -u flag this time. This process simulates exactly how your device's firmware will communicate with the platform. I will execute the command now. As you can see, the terminal received a ACK confirmation, and the inspector shows the device data, meaning the data has been correctly stored in your bucket. Finally, we will map this verified data to a visual display. Create a new dashboard and add a gauge or display widget, for example. Select your device and the variable named defined in your command, in this case, temperature. The widget will now update in real time as TCP frames are received. This completes the full integration from terminal to dashboard. You have now successfully implemented a complete TagoTiP over TCP data flow. From here, you can utilize analysis to run complex logic on your incoming data, set up actions to trigger alerts, or build advanced dashboards to share your insights with users.